Hello friends, welcome to my channel. Let's have a look at problem 2426, number of pairs satisfying inequality relation. In this video, we're going to share two formats of solutions based on binary search or sorted containers. So first, I'll read through the statement of the problem to digest the task, and then we do some transformations, and finally we share the code. Let's look at the problem statement. We are given two zero-indexed integer arrays, nums1 and nums2. They have the same size, and an integer called difference. So find the number of pairs ij such that I and j are in range and I is strictly less than j, and the following relationship holds. So it involves the two lists nums1 and nums2, and two indices ij as the difference. So we are required to return the number of pairs that satisfy the condition. So here are two examples. So in example 1, so the return is 3. So it specifies the 3 pairs of indices in the explanation. So you can do a check. And in example 2, so there are no indices pair satisfying the relation, so the return is 0. So actually here is only one pair of indices, that is 0, 1. We just need to do one check. So before we analyze the problem, let's look at the constraints. So the first constraint actually says that the two lists have the same length, and the second one says so their length is bounded above by 10 to the power 5. And the third one is on the element range in the two lists, and the last one is on the range of the difference variable. With that said, let's look at the method. So here actually we are going to use use the idea of binary search. So here this star is the condition, so it actually involves two indices and two nums array. So this star actually is equivalent mathematically to the double star in the second equation. So however, these two equations are not exactly the same in view of coding. So the reason is that the equation double star actually has some advantages. So if we look at the left side and the right side, we notice that ij are decoupled. The left hand side involves only I, the right hand side involves only j, right? So which will enable us to examine the difference list, right? So we can compute the delta, so that is x minus y for xy in the corresponding list. And then actually the procedure will be routine. So the thought is the following. So for each element in the difference list, so we look at it corresponds to an index j, right? So we want to find how many previous indices I can pair with j and satisfy the double star. So this is our overall thought. Actually, to carry out the procedure, so we could use binary search or we can use sorted containers. So this will be more clear if we look at the code later. So before we write the code, actually here are some extensions. So this problem actually can be solved using a segment tree, but we need to implement the segment tree abstract data type before we write problem logic. So this is actually the hinting method by the problem statement. So this is one comment. Another comment is that so we can use the idea here to examine Leetcode problem 493, so reverse pairs. So actually problem 493 is more direct compared to this problem, because in this problem we need the transformation from star to double star to make the two indices decoupled. So with that said, so we are ready to look at the code. So I'm going to use the same idea and share two different formats of solution code. So the first one is a pure binary search, I would say. Binary search. So for this, actually We do not need to explicitly specify the difference sequence, but for the purpose of presentation, let me write it here. So x, so see a minus b for a, b in zip, we're going to use this functions, nums1, nums2. So this list comprehension will give us the difference list, and then we can actually try to find for each index the previous indices i's, which can pair with the current index j. So for this, I'm going to initialize a auxiliary list. So this will store the previous indices if we look at an index j, right? So then also we need to initialize a result variable which counts the number of valid pairs. So the final state of this result variable is what we need to return. And then next basically is a for loop. So for y in delta. So notice that we didn't explicitly use the index j. The reason is that each of the elements corresponds to one indices j, and the aux will store the previous indices when we look at the y currently. So then the thing is very simple. So what we are going to do is that, so we are going to increment the result. So we want to count in the aux. The aux will be sorted. So we are going to count how many numbers are smaller than some number. So let's see, bisect. So we're going to use bisect right. So we're going to bisect, consider this one. What we are going to search is actually y minus the difference. So in other words, we want to look at, so let's look at y. So we want to look at in the aux list how many elements is less than or equal to y, right? So if this is the case, we're going to increment this result by the number. So let me write it in this form. So let's call this is count. So this bisect will return us a index. So for example, the index is count, which means that all the indices less than this count will contain smaller number than this y, right? So then we are going to increment this result by count. So here it's important to notice that we store y minus delta, the difference in the aux. So what we are going to do is that, so we're going to use bisect insert. So we insert this aux with the y minus diff. So this way, the previous pair, the previous difference minus difference will be less than the current element. In other words, the current element plus difference will be larger than the previous difference. That's exactly the problem asks. So with that said, actually we can return result. So here it's important that we use bisect right. So bisect right will make sure that the left, the smaller index less than count corresponds to elements less than or equal to this y, right? So we need to count equal because the relation in double star count is less than or equal to. So with that said, this forms a format of solutions. So let's first do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So here actually, as for where we store, what we store in the aux, so we have some freedom. So if here we check y plus difference, so what we are going to store here will be y, right? So if we do the check again, so it will do the same thing essentially, right? So this is the one solution format. So we're using bisect or binary search. So here the insert, so we can use insert left or insert right. So it's the same thing. But here the bisect right is important because we want to count the case of equality. So with that said, this is finished the first format of solution. So let me copy this function signature and do another format. So essentially they are the same method. So what we are going to do is that we're going to use sorted container. For this purpose, let me sorted containers import, so we can use sorted list. So here actually essentially this operation will maintain the list being sorted. So now let's use sorted container to do this directly. So what we're going to do is that we're going to use sorted list. So what we're going to do is essentially the same. So let's copy this part, and we initialize this aux to be sorted list, and then we're going to do the counting. So let me also copy this part. So here what we are going to do is that we will change this a little bit. So we use the aux bisect right method. So here let's use y plus difference, and then what we're going to do here is change this line. So we're going to aux and, so because here we are checking y plus difference, we're going to add y. Then we can check the cases. Yeah, it passes one special case. Now let's look at the generic case. Yeah, it passes all the cases. Now if we check here, we check y, and then here we should store y minus difference. Same thing. So now let's do the check directly. Yeah, it passes all the test cases. So that's about it for a solution to this specific problem. And in this video, actually we shared two formats of solutions based on the same idea, essentially binary search. So here in the first format, we used the bisect right function. So this is the main point. And in the second, so still the bisect right function, but it's a method of the object aux. And then in between the two methods, when we do the storage for things in the aux, we can store either the difference itself or the difference minus the diff variable, so accordingly. So with that said, I guess that's about it for this video. Thank you.